In this video, we are going to discuss ray diagrams for concave mirrors. ఈ వీడియో చివరి వరకు చూడండి so that you will understand how position of the object is going to affect various properties of the image. Okay, concave mirrors కేసులో position of the object అనేది image properties ని ఎలా affect చేస్తుంది అనేది you are going to understand. Okay. Let us quickly recall about ray diagrams. Ray diagrams are simplified graphical representations used to understand the image formation. అర్థమైందా? Ray diagrams use చేసి we can understand how image is going to get formed and whether the given image is going to be real image or virtual image. And with the help of ray diagrams, we can say whether given image is inverted image or upright image. Whether the image is magnified or diminished in size. And with the help of ray diagrams, we can find the distance of the image from the mirror. You see, this is the benefit of drawing ray diagrams. Let's say I have a concave mirror here and a burning candle here, and this is the screen, right? On the screen, you can see the image of the candle. It is inverted in shape and small in size, right? Now the question is, if I want to understand where can I place this screen such that I can see the image of this candle clearly, then ray diagrams are going to be useful. And second thing is, what is the size of this image? You will be able to say that with the help of ray diagrams. Okay. And in the previous video, we have learned about 3 rules to draw specific rays and how their reflected rays are going to be. Okay, what are those 3 rules? Rule number 1, it says that if incident ray is parallel to the principal axis, then the reflected ray is going to pass through the focus of the mirror. Please remember this. If incident ray is parallel to the principal axis, then the reflected ray is going to pass through the focus of the mirror. Rule number 2, if the incident ray passes through the focus of mirror, then the reflected ray is going to be parallel to the principal axis. Understood? The third one is, if incident ray passes through the center of curvature, then the reflected ray goes through the same path but in opposite direction. ఈ 3 రూల్స్ మీకు తెలిసి ఉండాలి సో దట్ యూ కెన్ డ్రా రే డయాగ్రామ్స్ ఈజీలీ. ఓకే, దిస్ ఈజ్ ఎ కాన్కేవ్ మిర్రర్, రైట్? C denotes center of curvature, F is focus of the mirror, and P is pole of the mirror, right? And this line is called principal axis. Now we want to draw a ray diagram for an object. You see, this is the object. You have a candle kind of object, right? I want to draw a ray diagram for this. For that, what I'm going to do is, first, rule number 1, it says that if incident ray is parallel to the principal axis, then the reflected ray is going to pass through the focus of the mirror. So what I'm going to do is, let me call this as AB. This tip is called A, right? I want to represent this tip in the image. For that, at least 2 rays I need, right? The first ray I'm going to draw is parallel ray. From point A, I'm going to draw a ray parallel to the principal axis. After hitting the surface of the mirror here, it has to reflect, right? The reflected ray is going to pass through the focus of the mirror. Focus is F, right? So the reflected ray is going to pass through focus of the mirror. మనకి ఈ రూల్ గుర్తులేదనుకోండి, still you can draw these rays. First, what you have to do is, you have to draw normal to this point of incidence. Once you know the normal, you find what is the angle of incidence, and you say that angle of incidence is equal to angle of reflection, and based on that you can draw the reflected ray. But here, just with the help of this particular rule, we can draw reflected ray much easy, right? Now I'm going to draw one more ray from point A, because I need two rays to represent a point in the image, right? So the second ray, for that what I'm going to do is I'm going to use rule number 2. It says that if incident ray passes through the focus of the mirror, then the reflected ray is going to be parallel to the principal axis. So from point A and a point nunchi, I have to draw a ray which passes through focus. F nundi pass avvali A nunchi. This is the incident ray. Now the reflected ray is going to be parallel to the principal axis. Fairly easy, right? This is the point of intersection of these two rays, reflected rays, which are coming from point A. This is point A in the image. Let me denote this as A prime. Understood? Now I have point B. I want to represent that also in the image. For that, let me draw a parallel ray to the principal axis from point B. Now, as per the rule 1, it has to pass through the focus of the mirror, right? Let's draw that. From point B, again, I have to draw one more ray, because two rays at least I need, and where they intersect, that is the point where I'm going to have the image for B, right? So let me draw another ray that is going to be using rule number 2. Rule number 2 says that the incident ray has to pass through the focus, meaning the incident rays should start from B and should go through F. Then from this point it has to reflect. When it reflects, it is going to be parallel to the principal axis, right? Let's draw that. Now this is the point where these two rays, reflected rays, got intersecting, right? Let me denote this as B prime. This is image of B. Please note this. Now we know point A and point B ka reflections as A prime and B prime. If you connect these two, what you are going to get is the image of it. Of course, you can put point C here, C, or let me call this as K, L, M, like that. You can put many, and you are going to get K prime, L prime, M prime, kind of image reflections you are going to get. Understood? This is how you are going to draw ray diagrams. When you look at this ray diagram, you can say that AB, size of AB in the image is reduced, right? And second thing is the image is inverted. So this kind of information you can get. Now, if you know what is the distance between P and this particular point, this is the distance from the pole to the image. Understood? These kind of things, if you want to do, you need ray diagrams. That is one. And remember, here we have taken A and B as two separate points away from principal axis. In general, what we do is we don't take point B away from principal axis. We will be taking point B on principal axis so that it becomes easy to draw ray diagrams. Here, what you have done is a set of rays for A and another set of rays for B you have done, right? When we have, let's say, my object like this, only A, I have to find out where the position of the image for point A. Then B is automatically going to be on the principal axis corresponding to A prime's position. B prime ka position is going to be in line with A prime's position. You will understand all that, but in the upcoming examples, we are going to make use of this kind of object. Rather than taking B and A in different positions corresponding to principal axis, what I'm going to do is B is going to be always on principal axis. So that, construction of ray diagram is fairly easy. Understood? Please note that position of object is going to affect the properties of the image. Properties of the image and position of the image. Whether the image is going to be real or virtual, whether the image is going to be inverted or erect, magnified or diminished in size. All these are going to be affected by where the position of the object. Okay, ఈ పర్టికులర్ డయాగ్రామ్ చూసారనుకోండి, మీకు యూ హ్యావ్ సెంటర్ ఆఫ్ కర్వేచర్, focus and pole, right? My object can be here, or my object can be here, right? Let's say this is far away, let me call this as infinity. My object can be at very far away from the mirror, or my object can be slightly away from curvature, or the object can be on the curvature, right? Center of curvature, or the object can be in between F and C, or the object can be on F, or the object can be between P and F. You know, these are different possible options, right? In the case of concave mirrors, what happens is, depending upon where the position of the object, it is going to affect properties of the image. For example, position of image, real or virtual, inverted or erect, magnified or diminished, all this is going to get affected depending upon where the position of the object is on this. So object positions can be, as I said, it can be between mirror and F. It means it being between P and F. At the focal point, meaning the object can be at F, between C and F, at the center of curvature, or beyond C, right? We are going to learn now how it is going to affect image position, how it is going to change whether the image is going to be real or virtual, enlarged or diminished, erect or inverted. We are going to learn about all this by drawing ray diagrams for the objects at these different positions. Understood? Let us start with having an object at the center of curvature. Ante C దగ్గర exact curvature of center of curvature for the mirror ఎక్కడ ఉందో అక్కడ, let's say you have an object. Now, where its image is going to be, and what about its size? Is it going to be inverted or erect? All that we are going to learn. For that, we have to draw ray diagrams, right? For drawing ray diagrams, we will be using rules. Rule number 1, it says that if incident ray is parallel to the principal axis, then the reflected ray is going to pass through the focus of the mirror. So let me call this as A, B. What I'm going to do is, I'm going to see where point A is located in the image. Point B, I don't really need to worry. I'll tell you how to do it. Without drawing rays from point B, we can simply do it. I'll show you how to do it. But let's do now for A, point A, how it is going to be represented in the image, or where it is going to be represented in the image. For that, we are going to draw 2 rays, right? First ray, it is going to be based on rule number 1. I am going to draw a ray from point A parallel to the principal axis of the mirror. Then it reflects and passes through the focus of the mirror, meaning it has to pass through this point, right? So it has passed. Now, from A, I have to draw another ray, right? For that, I am going to use rule number 2. It says that if incident ray passes through the focus of the mirror, then the reflected ray is going to be parallel to the principal axis. So let me draw a ray from A that passes through F. Okay, this is the point of incidence. From here, it has to reflect, and the reflected ray is going to be parallel to the principal axis. So you see, these 2 reflected rays have intersected here, right? Means this is the point of A in the image. Let me denote this as A prime. Now, B prime is going to be at exactly perpendicular. From A prime, if you draw a line like this, perpendicular line, where it touches the principal axis, there you are going to have B prime. You understood? So let me draw the image now. You see, if you observe, image is showing up at C itself, center of curvature. Wherever you have center of curvature, that point itself you have now the image, right? And image is in front of the concave mirror, right? Such images we are calling them as real images because we can project this image on a screen. Backside mirror backside oste ganaka we can't project on the screen. If it is on the front side of the mirror, we can project the image on the screen. That's why you can say that this is real image. And when you look at size of this particular image is same size as that of the object. And you have seen that it is inverted, right? Image AB la unte ganaka idi invert ayi B prime A prime la undi, right? Let's note that. ఈ టేబుల్లో నోట్ చేసుకోండి. ఆబ్జెక్ట్ అనేది సెంటర్ ఆఫ్ కర్వేచర్ దగ్గర ఉంటే ఇమేజ్ పొజిషన్ వచ్చి సెంటర్ ఆఫ్ కర్వేచర్ దగ్గరే ఉంటుంది. ఇమేజ్ ఈస్ గోయింగ్ టు బి రియల్ అండ్ ఇట్ ఈస్ గోయింగ్ టు బి ఆఫ్ సేమ్ సైజ్ అండ్ ఇట్ ఈస్ గోయింగ్ టు బి ఇన్వర్టెడ్. అండర్స్టూడ్? Let us now learn how properties of image is going to be affected if the object is positioned in between C and F. I have an object here, right? Let me call this as AB. Now I want to represent point A in the image. For that I am going to draw two rays, right? Let me take rule number 1 and draw a ray, incident ray parallel to the principal axis. Once it hits the surface of the mirror, it has to reflect, and that reflected ray is going to pass through focus of the mirror. Let me draw that. Now let me take the second ray from point A. For that I am going to use rule number 2. It says that if incident ray passes through the focus of the mirror, then the reflected ray is going to be parallel to the principal axis. Meaning I have to draw incident ray which is passing from A and F. Okay, then the reflected ray is going to be parallel to the principal axis. Now you see, this is the point where these two reflected rays are intersecting. This is going to be A prime. The image of A is denoted using A prime. Now what I am going to do, from A prime I am going to draw a vertical line which is going to get connected on the principal axis at this point, that is called B prime, right? Now connect these two, then you are getting the image of AB, right? You observe this. The image position is beyond C, right? Or otherwise you can say that the image position is in between C and infinity, right? And image is real because I can project this on a screen. And if you observe, the image is enlarged. The size of image is bigger than size of the object, right? And the image looks inverted. Let's note that. So when the object is between C and F, the image is going to be beyond C, and it is real, it is enlarged and inverted. Understood? Now let's look at another case where the position of object is at focus, meaning the object is at F itself, right? Now I want to see where the image is going to be. Let me call this also as AB. I have point A, right? Point A ka image we are going to see first. For that I am going to draw two rays. The first ray is, as usual, we are going to draw an incident ray which is parallel to the principal axis from point A, and it has to pass through focus. It has passed through focus, and now I am going to take rule number 3 in this case to draw the second ray from point A. That rule number 3 says, if incident ray passes through the center of curvature, center of curvature ante C, right? దీని నుంచి గనుక ఇన్సిడెంట్ రే పాస్ అయితే then the reflected ray is going to also pass through the same path but in the opposite direction. Please note this. So let me draw an incident ray that is going to pass through center of curvature and A, right? Because మనం A ని represent చేద్దాం అనుకున్నాం కదా. So let me draw that. This is the ray which is passing through center of curvature and going through point A, right? It has point of incident at this point, right? It has to reflect. When it reflects, what happens? It is going to reflect and goes through the same path. అంటే ఈ పాత్రలోనే వస్తుంది బట్ ఆపోజిట్ డైరెక్షన్లో వస్తుంది. లెట్స్ సీ దాట్. యు సీ లైట్ కలర్ బ్లూ is showing the opposite direction, right? Now if you observe these two, first reflected ray is here, the second reflected ray is here. These two rays are looking parallel, right? You may recall that, if the rays are very looking parallel, at infinity they are going to meet, right? At infinity, if they are going to meet, for example, then I'll be having A prime, let's say, beyond the screen. Screen దాటేసి ఎక్కడో ఉంటుంది A prime అనేది, రైట్? ఇవి రెండు ఈ రే ఇలా వెళ్ళిపోతున్నాయి. స్క్రీన్ దాటి చాలా దూరం వెళ్ళిపోయిన తర్వాత డౌన్వర్డ్స్ వెళ్ళిపోయిన తర్వాత ఎక్కడో మీట్ అవుతాయి. ఆ మీట్ అయిన పాయింట్ని A prime అంటాం. ఓకే, అండ్ B prime ఈజ్ ఆన్ ద ప్రిన్సిపల్ యాక్సిస్, రైట్? B కరస్పాండింగ్ B ప్రైమ్ ప్రిన్సిపల్ యాక్సిస్ మీద, A ప్రైమ్ మాత్రం చాలా దూరం వెళ్ళిపోయింది. నౌ యూ అండర్స్టూడ్? సో ద పొజిషన్ ఆఫ్ ఇమేజ్ ఈజ్ గోయింగ్ టు బి ఎట్ ఇన్ఫినిటీ. అంటే చాలా దూరం వెళ్ళిపోయాక కలుస్తున్నాయి అనుకుంటున్నాం కాబట్టి ఏ ప్రైమ్ పొజిషన్ అనేది ఈ స్క్రీన్లో ఉండదు, చాలా దూరంగా వెళ్ళిపోతుంది. దట్స్ వై యూ సే దాట్ image position is going to be at infinity and the image is going to be real because of course we can't put a screen at infinity, but there is a possibility. Infinity ante, let's say it is much beyond this particular whiteboard you are seeing, right? In that case you can still say that the image is going to be real and the image is going to be infinitely large. ఎందుకు infinitely large అవుతుందంటే A prime అనేది స్క్రీన్ దాటి వెళ్ళిపోయింది అండ్ B prime అనేది ప్రిన్సిపల్ యాక్సెస్ ఏదైతే ఉందో దాని మీదకి వస్తుంది, రైట్? అందు గురించి ఇమేజ్ అనేది చాలా పెద్దదిగా ఉంటుంది అండ్ ఇమేజ్ ఈజ్ గోయింగ్ టు బి ఇన్వర్టెడ్. అండర్స్టూడ్? లెట్స్ టేక్ ఎ నోట్ ఆఫ్ దిస్. వెన్ యూ హ్యావ్ ఆబ్జెక్ట్ హియర్ ఆన్ ద ఫోకస్, ద ఇమేజ్ ఈజ్ గోయింగ్ టు బి at infinity, meaning it is beyond the screen. And the image is going to be real and it is going to be infinitely large compared to the object and it is going to be inverted. Understood? Let us now learn what happens if the object is in between mirror and F. Mirror ne P andam, in between P and F object unte ganaka how the image is going to be ane chuddam. So we are going to use again two rules. Rule number 1, let me call this object as AB. I want to mark where A is going to be in the image, right? For that I am going to draw two rays from point A and the first ray is going to be parallel to the principal axis and then it is going to reflect such that it passes through focus. Now I have to draw second ray from point A. For that I am going to use rule number 3. If the incident ray passes through the center of curvature, then the reflected ray goes through the same path in opposite direction, right? It means I have to have an incident ray which is passing through C and A, right? Now it has to reflect from this point. You observe this. The reflected rays, this one and light blue line here, these two are diverging, right? These two are going away from each other. Means they must be appearing as if they are coming from behind the mirror, right? For example, if I enlarge or extend these rays, reflected rays ni mirror back side ki extend chesanu anukondi, then they are meeting at this point, right? This is the point where you have A prime. Please note this. That is A prime, and A prime nunchi you draw a line perpendicular to the principal axis, and that is called B prime. And let me denote the image here. You see, the image is much larger in size, right? And it is behind the mirror. Behind the mirror, aithe ganaka, you say that that image is a virtual image, right? Because we can't project it on the screen. మనకి ఈ పర్టికులర్ పాయింట్ నుంచి లైట్ ఏ ప్రైమ్ అనే పాయింట్ నుంచి లైట్ వస్తున్న ఫీలింగ్ వస్తుంది, రైట్? బట్ దట్ ఈస్ నాట్ ఏ రియాలిటీ. ఎనీవే, వాట్ యూ హ్యావ్ సీన్ ఈజ్ ఏ ప్రైమ్ బి ప్రైమ్ ఈజ్ మచ్ లార్జర్, and the image position is behind the mirror, and it is enlarged in size, and it is a virtual image. And once you say virtual image, it is going to be erect. Please note this. Let us mark this also. Okay, when the object is between P and F, the image is going to be behind the mirror, and it is going to be enlarged, and it is erect, and it's a virtual image, right? The next case we are going to see is what happens when the object is beyond C. Now we have to draw ray diagrams for this, right? Point A, I'm going to use rule number 1. Rule number 1 says that the reflected ray, when the incident ray is parallel to principal axis, reflected ray has to pass through focus of the mirror. And the second ray I'm going to draw is based on rule number 2. Of course, you can use rule number 3 also. If you use rule number 2, then I have to draw a ray from point A and passing through F, such that this is the point of incidence, right? Now, rule number 2 says that the reflected ray is going to be parallel to the principal axis. These two rays are intersecting at this point. This is going to be my A prime. Then B prime is going to be on the principal axis, right? The image is going to be inverted. Understood? So, look at this. The image position is between F and C, right? And the image is going to be real, and it is diminished in size, and it is inverted, right? Now let's note this. We have seen what happens when the object is here, or when the object is at C, when the object is between F and C, when the object is at F, and when the object is between P and F, right? In all these cases, we have seen slightly different kind of images forming, right? In one case, it is infinitely large. In other cases, you have seen enlarged. This is same size, this is diminished. In all these cases, the images are real, but here it is virtual, right? When it is virtual, it is erect, and when it is real, the image is going to be inverted, right? ఈ టేబుల్లో ఉన్న పాయింట్స్ మీకు గుర్తుంటే బెటర్, అదర్వైజ్ యూ నో హౌ టు డ్రా ద రే డయాగ్రామ్స్ అండ్ చెక్, రైట్? ఎందుకంటే దీన్ని బేస్ చేసుకుని మనకి బిట్ మార్క్స్ క్వశ్చన్స్ కూడా రావచ్చు. ఫర్ ఎగ్జాంపుల్, ఇన్ఫైనైట్లీ లార్జ్ ఇమేజ్ కావాలంటే వేర్ యూ హ్యావ్ టు ప్లేస్ ద ఆబ్జెక్ట్, ఇలాంటి క్వశ్చన్ అడిగారు అనుకోండి, దెన్ యూ షుడ్ నో, రైట్? I hope you got the concept.